awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih.
Assalamualaikum and hi everyone. So welcome back. Jadi dalam video kali ini kita nak discuss beberapa soalan berkaitan dengan subtopik 4.1 which is under subtopik work. Okay, so kita nak tengok exercise berkaitan dengan flat surface and then kita akan move kepada second part which is exercise berkaitan dengan inclined plane. Okay, so kita akan mula dulu soalan dengan soalan exercise berkaitan dengan flat surface. Jadi saya rasa kalau flat surface ni tak ada masalah, ramai pelajar boleh buat selalunya. Okay, masalah selalu timbul bila nak buat soalan yang berkaitan dengan inclined plane. Okay, jadi untuk video kali ini kita hanya fokus kepada bagaimana untuk kita kira work done by the external force, work done by the friction, okay, ataupun kita nak kira the total work done. Alright, so now let's start with the first question. Okay, so ini saya dah sediakan table kat sini. Jadi kita boleh tengoklah. So let's say the first situation we have the flat surface and this is the object. Alright, so the external force is equal to 5 Newton. Means that we will try to move the object to the right. Okay, sejauh berapa ni? Displacement dia adalah 10 meter. Okay, so saya nak besarkan sikit ni. Okay, kita besarkan sikit lah. Alright, so now calculate work done by the force F. So in this case, we want to calculate what is the work done by the external force F. Alright, so remember the equation, alright, of the work done is equal to Fs cos theta. Alright, means that this is a dot product. Okay, so W is equal to Fs cos theta. Saya percaya you dah ingat lah equation ini. Okay, jadi bila kita nak kira, okay, work done. So in this case, the first thing you must look at the angle between the force and the displacement S. Alright, so for example here, we have the, this one, the direction. Okay, the direction of S to the right and the direction of F also to the right. Means that theta is equal to 0 degree. Sebab mereka parallel. Selari in the same direction. Alright, so the work done by the external force F, saya suka tulis macam ni. And it is equal to Fs cos theta. Alright, and in this case, we have F is equal to 5 S tan cos 0 and the answer is equal to 50 joule. Alright, so unit jangan lupa. Okay, and then for the B, okay, for question B here. So in this case here, we have a force, okay, and the force is at angle of 60 degree to the horizontal. Kalau tadi force kita to the right, which is parallel to S, this time force kita ada angle. Jadi bila ada angle macam ini, kita nak kira the work done by the external force of 5 Newton. Okay, so based on the definition of the dot product W equal to Fs cos theta, actually, okay, the force here, okay, we need to choose a force that is parallel with the displacement S. Sama ada dia parallel same direction ataupun dia parallel opposite direction. Okay, saya akan tunjukkan dua cara. Okay, terpulang kepada awak nak pilih yang mana untuk lebih mudah awak jawab dengan betul. Okay, for example, for the first method. Okay, saya kecilkan sikit. Okay, the first, alright, so yang pertama, for the first method, okay, let's say method 1, okay, so we just look at the angle between F and S. Okay, kalau saya suka lukis macam inilah, S to the right, and this is F, where the angle between F and S is 60 degree. Okay, so based on this angle, so WF should be equal to 5, S is 10 cos 60 degree. Okay, and then the answer would be 25 joule. Alright, so this is the answer. Ataupun katanya you nak resolve F into X and Y component. Boleh. Okay, so dia akan jadi this is Fx and this is Fy. Okay, where fx is equal to f cos 60, while fy, okay, saya betulkan sikit, fy is equal to f sin 60. Okay, so for work, okay, it is a dot product, means that the force F here, we need to choose the force that is parallel with S. So between Fx and Fy, we look at here that Fy is perpendicular to S, 90 degree. So cos 90 degree will give you 0. Okay, so in order to get the work done by the force, so F here should be Fx. So we choose force that is parallel to the S. Okay, so to the displacement. Alright. Okay, so W here, okay, the work done, Fx is equal to Fx s cos theta. And in this case, okay, direction of S to the right and Fx also to the right. So the angle is equal to 0 degree. Therefore, W, the work done by Fx is equal to, Fx here is F cos 60 times S times cos 0, and it should equal to 1. And times cos 0, and cos 0 should be equal to 1. So 5 cos 60 times S, which is 10 meter, and times 1, this is cos 0, 1, and the answer is equal to 25 joule. Alright, so some of the students prefer to resolve the force with angle 60 degree to the horizontal into X and Y component. Okay, so dia akan buat macam inilah, so you jangan confuse. Okay, sebab setengah buku pun dia akan buat macam ini. Okay, dia ada ini. So I will write here method 2. Okay, so if you prefer to resolve the force and then choose the force that is parallel to S, sama ada dia parallel in same direction or opposite direction. Kalau same direction maknanya macam inilah, S to the right, Fx to the right. Ataupun kalau opposite direction, Fx to the left, S to the right, macam tu. But if the force is 90 degree with the displacement, okay, cos 90 akan bagi you 0 lah. So kita tak pilih Fy. Okay, boleh Okay, tapi kalau rasa you tak nak resolve macam ini, you prefer nak ambil angle between F and also S, like this one. Okay, so sini kita tak masukkan F cos 60 lah, kita ambil terus F. Sebab dekat sini adalah Fx. Okay, saya highlight. So you nampak beza dia. Okay, so sekarang kita tengok pula C. So we want to move the box to the right, okay, and the displacement is 10 meter. But we put a force and the direction is upward, 5 Newton. Adakah box ini akan bergerak ke kanan kalau external force dia ke atas? Okay, so kalau kita kira WF, it should be Fs cos 90 degree. Okay, since S is to the right and F is upward and the angle between them is 90 degree. Okay, so 90 degree is equal to 0. So this one should be straightly equal to 0. Okay. Alright. Next. Alright. So let's look at D. So here we have D. Okay. The force is 5 Newton and the angle between S is 120 degree. Alright. So 120 degree is this angle. Okay. So if you follow the first method, okay, let's say you want to use method 1. Okay, means that S in this direction and F in this direction. And the angle between them is 120 degree. Okay, so WF should be Fs cos 120 degree. So we can straightly substitute F equal to 5, S is 10, cos 120, so you will have negative 25 joule. Okay, so this is the answer. But if you want to follow the second method, okay, I will write method 2. Okay, so let's say for method 2, look at here. So we can put the y-axis here. Okay, for example, let's say this is the y-axis and this is 90 degree. And here should be 90, 30 degree. Okay, I will put red color here. Okay, so the red angle here should be, this one should be 30 degree, sorry, 30 degree. Okay, and the green color here should be 90 degree. Okay, so if you want to use second method, let's say you want to resolve f into fy, okay, and fx. Okay, so antara fy dan fx, okay, you can see here that fx and s is parallel but opposite direction. Okay, and fy and s is perpendicular, 90 degree. Okay, so in 90 degree kita tak pilih fy, kita akan pilih fx. But the angle, okay, the angle between s and also fx is 180 degree. Okay, so I will choose fx in this case. So now the work done by the external force, so if you resolve, then we choose fx. So dekat sini dia akan jadi fx s cos theta. And theta is the angle between fx and s, and it should be equal to 180 degree. And now when we substitute fx, fx kita sama dengan apa ni? Fx kita adalah f sin 30 degree. Okay, so you can write here fx is equal to f sin 30 degree. Okay, and then times s is 10. F ni boleh masukkan teruslah, 5 Newton. And then times negative 1 cos 180 degree is equal to negative 1. Okay, and then you akan dapat jawapan yang sama, negative 25 joule. Okay, jadi ini saya selalu pesan dengan student, it's up to you. Okay, you prefer method 1 or method 2. Okay, everything is up to you. Okay, so mungkin certain book you nampak akan guna method 1, ada yang guna method 2. Okay, tapi jawapannya tetap sama. Okay, cumanya method 2 dia lebih kepada follow the definition of the dot product. That's mean we need to choose a force that is parallel to S. So kita ambil fx. Tak ambil fy sebab fy adalah perpendicular to S, 90 degree. Okay, and E, this is very simple. So F, okay, kita tak perlu resolve sebab tak ada angle ke apa. Okay, so kita akan nampak dekat sini, S is to the right, F is to the left, and the angle between them is 180 degree. Okay, they are parallel but opposite direction. Okay, so this is very easy. We can straightly calculate cos 180. So 5, 10, this is negative 1. Cos 180, negative 1. And then the answer is negative 15 joule. Okay, alright, now we finish exercise for flat surface. Okay, how about inclined plane? Okay, so basically, look at here, we have a value of force, external force, frictional force, and also displacement. Okay, but the direction of the first question, the external force, look at here, that the direction of the external force is parallel to the base of the inclined plane. Okay, tapi yang kedua ini, direction of force is parallel to the surface of the inclined plane. Okay, objek tu bergerak on this surface and the force is parallel to the surface. But this one, the force is parallel to the base, tapak dia. Berbeza. Sama ke nak selesaikan soalan dua ni? Tidaklah, berbeza. Look at the direction of the force. Alright, so now let's start with the first one. Okay, so I would prefer to highlight, okay, the direction of the external force F, where it is parallel to the base, yang color kuning ini. Okay, and then to make it easier, okay, I will try to sketch a line that is parallel to the surface. Okay, this one should be parallel, should be straight line. Okay, macam itulah. It should be straight line. Okay, this one is parallel to this one. Okay, saya tarik sikit saja sini. Okay, so look at the blue and the yellow line. If the angle between blue and yellow line is 25 degree, means that if the yellow line here is parallel, sama, selari, and the blue line here also parallel, so mathematically, the angle between the blue line here and the yellow line here should be equal to the angle here, 25 degree. Okay, this should be the angle. Okay, which is 25 degree. Boleh. Okay, so now the first question, we want to calculate the work done on the box. Alright, so the first question, we want to calculate the work done on the box by the force F. Okay, so look at here, we have F. Okay, if I put the force, okay, in the free body diagram, for example. Okay, so it should be, kalau kita lukis dekat sini, dia akan jadi macam ni lah. Y-axis and this is x-axis. So, the free body diagram, okay, F kita akan jadi macam ini. Okay, kita pindahkan dia. Okay, you tengok dekat sini. This is direction of F. So, this is the x-axis. X-axis mesti dekat surface yang objek itu bergerak. This should be x-axis and this should be y-axis, perpendicular to the surface. Okay, so F dekat sini and this angle is 25 degree. So, F dekat sini lah. Kan? Cumanya kita tegakkan sikit paksi X dan Y tu tadi. So, ini dia akan jadi 25 degree. Okay. And then the object is moving in this direction, S. The object is moving in this direction, S. So, in order to calculate the work done on the box by the force F, okay, so we can straightly calculate the angle between S. So, S ke sini, ke kanan, and F in this direction. So, the angle is 25 degree. Okay? Alright? So, kita boleh tulis teruslah. WF is equal to Fs cos 25. Okay? F is 250. S is 3.8 times cos 25. And the answer is equal to 861 joule. Okay, so this is the answer. Boleh? Okay. And then, how about, okay, the work done on the box by the gravitational force? Okay, so gravitational force is actually referring to the weight. Okay, so now, if we look at to this free body diagram, okay, the weight should be straightly downward. So W, and the angle here should be equal to 25 degree. Okay, the angle here should be equal to 25 degree. Okay, so sama juga macam tadi. Kalau kita nak resolve W, bila ada angle, kalau you kata you nak resolve, you boleh resolve. Contoh macam yang F tadi. Okay, kalau kita nak ambil angle terus F dengan S, boleh. Ataupun kata, saya nak resolve lah, saya suka resolve. It's up to you. So, let's say we want to resolve F tadi kepada Fx dan Fy. Okay? Okay, kalau saya buat macam ini, kita perlu pilih force yang mana? Fx ataupun Fy. Okay, we must choose the force that is parallel to the displacement. Sama ada parallel in opposite direction or same direction. In this case, you can see here that direction of Fx and S is the same direction, right? So, kita akan pilih ini. So, bila kita kira, okay, saya tulis tepi ni the work done by Fx should be equal to Fxs cos 0. Kenapa cos 0? Sebab Fx dan S is the same direction. Angle dia kosong. Tapi dalam ini bukan F, tetapi Fx. So, tengok balik semula Fx. Fx duduk sebelah angle. So, it should be F cos 25. So, bila saya tulis dekat sini, dia akan jadi F cos 25 times S and this is equal to 1. So, jawapannya you akan dapat samalah 861 joule. Okay? And this is also the same situation. If you want to find what is the work done on the box by the gravitational force. Okay, W, weight dia lah. Ada angle. Okay, kalau you tak nak resolve W, okay, kita boleh kira terus. That's mean S in this direction. Okay, kalau saya buat style yang saya ingat sikit, ikut dia punya inclined plane. And then the W is straightly downward. Okay, so this is 90 degree. And another one here is, that one is 25 degree based on the angle of the inclined plane. Alright. So when we want to calculate work done by the gravitational force, awak kata awak tak nak resolve W. Boleh, tak ada masalah. Tapi sini mesti ambil W, S, and the angle between S and W is 90 degree plus 25 degree. And it is equal to 115 degree. Alright. So W here is equal to mg, and the mass is given 20 and g is 9.81 times s is 3.8 and cos 115. Okay. So kita kira lah. So you akan dapat negative 315 joule. Okay. Atau you kata saya nak resolve. If you want to resolve, okay, W into X and Y component, let's say here we have WX and here we have WY. So if you want to resolve into WX and WY, okay, so look at the angle between WY and S. The angle between WY and S is 90 degree, right? So we cannot choose WY in this case because cos 90 degree will give you 0 value. But we need to choose WX. It is parallel to S but in opposite direction. Remember? Okay. So the angle here is 180 degree. Therefore, the work done by the gravitational force, so in this case, I will choose WX. Okay. So WX times S cos 180 degree. Kenapa cos 180 degree? Okay. Why? Because of the angle between S and WX. 180 degree here. Okay, 180 degree here. But here is WX. Kalau dekat sini tadi W, dekat sini WX. Tak boleh letak W. Faham beza dia? Okay, so dia akan jadi WX is mg sin 25. Okay. Tak muat ni, saya tulis tepi sikit. Okay, so it is equal to W mg sin 25 times S times negative 1. Okay, cos 180 is negative 1. Boleh Okay, so bila kita masukkan nilai dia, mg sin 25, okay, you masukkan, you akan dapat sama, negative 315 joule. Okay, make sure masuk tu betul lah. Kira tekan calculator pun betul. Make sure your calculator is in degree mode, not in radian mode. Alright. So, if you prefer the first method, means that you just take the angle between S. S is in this direction, up inclined plane. Okay. And W is straightly downward. So, the angle between them is 115 degree. So, here you should use W. But if you want to resolve the work WX to WY, okay, and then we need to choose WX. Kita tak pilih WY because it is 90 degree with the displacement S. So we choose WX here. Not W, not WY, but here is WX. Jawapannya akan sama. So it's up to you. You nak prefer macam mana? You nak buat macam mana kan? Okay, boleh? Alright, good. Alright, next. Okay, so okay, the work done on the box by the reaction force. Okay, so the reaction force means that the normal force. Okay, so if S is in this direction, okay, N is in this direction, so it is 90 degree. Okay, so kita tak perlu kira pun tak apa. So the work done by the normal force or the reaction force should be NS cos 90. So cos 90 will give you 0. Therefore, Wn is equal to 0. Boleh? Okay, good. And then the work done by the frictional force. Okay, sama juga. Okay, S, okay, ke atas. up the inclined plane, and this is the frictional force. Okay, so the angle should be 180. Kan? 180 degree. So the work done, okay, on the box by the frictional force should be Fs cos 180. Okay, and then frictional force dia dah bagi tadi 20 Newton times 3.8 times negative 1. So the answer should be negative, which is 76 joule. Alright? So the work done is negative because that one is the work done to against the gravitational force. Okay? The work done by the system. Okay, the work done by the system to against the gravitational force. Okay? And then the total work done on the box. So kalau soalan minta kita kira the total work done on the box ataupun the net work. Alright? So it should be the work done by the external force F tambah dengan the work done to against the gravitational force Wg. Okay? This one we have negative value. The work done to against the gravitational force. Okay? And then plus the work done, okay, by the normal, tapi dia kosong tadi kan? Plus the work done by the frictional force. Okay? So 861 plus negative 315 plus 0 plus negative 76. Okay? And then the answer should be 470 joule. Okay? Itu cara kita kira lah. Salah satu cara untuk kita kira total work done on the box. Boleh? Kita kira satu-satu and then kita boleh tambahkan dia punya work tadi, kita totalkan terus. Alright. Okay, next. Okay. Okay, let's say, okay, look at the second diagram. Okay, the second diagram is actually easier to solve compared to the first one. Why? Okay, because here the direction of the force is parallel to the surface of the inclined plane. Okay, since the object is moving in this direction, we can see that the angle between F and S is 0 degree. Okay, so senang lah. Ini tak perlu resolve ke apa. S is in this direction, F also in this direction. So the angle between them is 0 degree. Okay, so W, the work done by the external force, is equal to Fs cos theta. So no need to resolve. Alright, no need to resolve F. Kenapa? Sebab dia dah memang parallel dengan S. So we just substitute 250 times 3.5 cos 0. Okay, cos 0 is equal to 1 and then the answer is 950 joule. Okay, kalau tadi the first part here we have 861. This we have 950. Okay, so for the same part, okay, for the same question, calculate the work done on the box by the gravitational force. Okay, that's mean gravitational force pun melakukan kerja untuk melawan pergerakan itulah because it is opposite direction Wx. Kan? S ke sini, Wx ke bawah. Boleh? So, bila kita nak kira, disebabkan semua situasi sama, external force saja yang berbeza. That's mean ini adalah external force daripada awak lah. Cumanya, ini kita tarik in this direction. And this one, we try to pull in this direction. Berbeza. Okay? Jadi, kerja yang dilakukan juga nilainya adalah berbeza. Tapi, in order to calculate the work done on the box by the gravitational force, okay, sama. Untuk case ni sebab soalan dia sama kan, kita tak perlu kira pun tak apa. Kenapa? Sebab diagram dia sama. Okay, W dia straightly downward. So kita cuba lukis sekejap. So this is the y-axis and this is the x-axis. Okay, so it is straightly downward. W. So the angle is here. Theta. Okay, so it's up to you. You can resolve into WY and WX. Okay. Kalau saya memang saya suka resolve lah. Kenapa saya suka resolve? Supaya saya nampak. Okay. The force yang we choose here adalah WX. Di mana WX ini opposite direction dengan motion. That's why jawapan kita dapat negative. Because that one is the work done by the system to against the gravitational force, to against its weight. Okay, in X component. So in this case, S, okay, and then you akan dapat WX. So dia akan dapat 180 degree. Tapi W ini samalah. Sini mesti WX equal to, here the force we must choose WX. Cos 180 degree. Okay, WX kita adalah mg sin 25. S 3.8 times -1. So, you akan dapat nilai sama -315 joule. Okay, tak percaya, cuba substitute nilai dia dan tekan kalkulator dan tolong check. Okay, jadi kalau kita perhatikan, hanya work done by the external force F saja berbeza. Okay, kalau first part tadi 861, here we have 950. Tapi yang lain mesti sama. Here should be 0 joule. Okay, and here should be -76 joule. But the total work done should be, tambahkanlah 950 plus -315 plus 0 plus -76. Dan jawapan akhir dia takkan sama lah kan? Jawapan akhir dia akan berbeza. Cuba kira berapa. Okay, 950. Sekejap ya. Okay, 950 minus 315. So, the answer is 635. Sorry. And then minus 76. 559. Okay, this is the answer. Boleh eh? Okay, good. Alright, and then let's try to move to another part. Okay, I have another 2 diagrams here. Okay, where the external force of F is in this direction. It is 60 degree. Okay, 60 degree to the surface of the inclined plane. Alright, so this is the surface of the inclined plane. Okay, and then the angle dia dah bagi 60 degree. Boleh? Jadi kalau saya transfer, okay, saya transfer 60 degree tu, kita lukis dulu, this is the y-axis and this is the x-axis. X-axis tu inilah, dia mesti parallel dengan plane tadi. Okay, so 60 degree kita nak ambil kat mana? Dia mesti dekat sini. Okay, 60 degree. Sorry, external force F. And here should be 60 degree. So, kotak tu akhirnya bergerak ke mana? So, in this direction S. Okay, displacement dia. So, if you want to calculate, okay, awak nak resolve ke tidak? Kalau kata nak resolve, boleh resolve. Okay, kalau kata nak resolve, awak boleh resolve F ini kepada X and Y component. So, we're going to have Fx and Fy. So, antara Fx dan Fy, kalau force itu 90 degree dengan S, because S is to the right, which is in this direction, and Fy is downward. So, Fy dengan S ni 90 degree. So, we can choose Fy. Based on definition of the dot product, we must choose Fx, which is parallel to the displacement S. Okay? Okay, ini method yang resolve lah. Dia akan jadi macam mana kalau you resolve? Okay, means that S is in this direction, Fx also in this direction. So, the angle is 0 degree. So, the work done by the external force Fx S cos 0. Tapi Fx tu, kita resolve tadi, dia akan jadi F cos 60 degree times S. Okay, cos 0 is equal to 1. So, 250 Newton cos 60 times 3.8. So, you will have 475 joule. Okay, ini method kalau you nak resolve. And then we choose Fx. If you prefer to take the angle, okay, we take straightly the angle between S and this is the Y component and this is the X component. So, F is in this direction. Saya ingat sikit lah ke bawah macam tu. F. Okay. So, the angle between them is 60 degree. Okay. So, you can straightly write F equal to Fs cos theta. Angle antara F dan S. Bukan angle antara Fx dan S. Okay. It should be 60 degree. Okay, kenapa saya tekankan dua method ni? Ramai yang confused sama ada nak resolve ataupun tidak. Okay, kalau you kata you nak ambil terus, so angle tu kena betul. Okay, so 250. Okay, S is 3.8. Sekejap times 3.8 times cos 60. So jawapannya akan samalah 475 joule. Boleh? Okay. Cuba yang sebelah kanan pula. Sama juga. F. Kita nak resolve. Okay, kita buat cara yang resolve dulu. Okay, so if you want to resolve F into Fx dan juga Fy. Boleh? Tak ada masalah. Okay. So, the direction of the displacement S in this direction. Okay. S in this direction. So, between Fy and Fx, okay, which forces is the same direction with S? Okay, either either Fy or Fx. Okay, so Fy is obviously 90 degree to S, but Fx and S is parallel, same direction, right? So the angle is 0. Okay, so if you want to resolve, we need to choose a force that is parallel with S. Sama ada parallel in the same direction macam ni ataupun opposite direction. Maknanya angle dia adalah 180. Okay, kalau untuk yang ni angle dia adalah, the angle should be 0. So why it is equal to 0? Okay, because the work done by Fx, we choose Fx, right? So it Fxs cos 0. Okay, 0 is the angle between S in this direction and Fx is in this direction. So the angle is 0. Okay, tapi kita resolve Fx tadi. Jadi nilainya apa? Okay, nilainya bukan F sahaja. Dia adalah Fx, which is F cos 60 times S times 1. So F is 250 cos 60. Sorry. Sekejap Okay. Cos 60 times 3.8. Okay. And then the answer is 861. Sorry saya masuk charger ni dia jadi macam ni. 861 joule. Okay. Kalau kata tak nak resolve boleh tak? Boleh. Boleh je kalau you tak nak resolve. That's mean S is in this direction. F tadi ke mana? F ke sini. Okay, where the angle between F and S is 60 degree here. Okay. So, if you want to find the work done by the external force F, bukan Fx tetapi F. Sebab kita tak resolve. So, dia akan jadi Fs cos theta. And then, F dia adalah 250. S is 3.8. And then, cos 60 lah. Angle antara F dan S. Jawapannya akan sama. 861 joule. Unit jangan terlupa. Boleh? Okay, very good. Okay, next. How about this one? The work done on the box by the gravitational force. Sama. Sama macam kita buat dekat atas tadi. Kenapa sama? Sebab inclined plane ni samalah. Kan? Tak perlu kira pun tak apa. Okay? Sama je macam tadi. Okay? So, kalau you nak guna, kalau you tak nak resolve, dia akan jadi macam ni tadi kan? S is in this direction, wake is straightly downward. So the angle between them is 115. Okay, so akan samalah. Work done by the gravitational force is mg, W lah. W S cos 115. So dia akan jadi mgs, nak masukkan nilai pun boleh lah. S dia is 3.8. Okay. Cos 115. So, you akan dapat jawapan sama macam tadi lah. Negatif 315 joule. Ini kalau you tak nak resolve. Kalau you kata nak resolve lah, saya suka resolve. Okay, saya suka method yang resolve. Tak ada masalah. You resolve. Okay. So, angle yang kat sini akan jadi 25. Okay, this one should be 25 lah. Okay. So, antara WX dan WY, kita kena pilih siapa? Siapa yang parallel dengan S? Sama ada parallel same direction or opposite direction. Okay, dah tentulah WX. Okay. It is 180 degree. Here. Sebab apa? Sebab S ke sini, WX ke sini. So, 180 degree. Okay, sorry for the bad writing. Okay. Sebab saya tengah charge ni, so dia punya surface tu agak terganggu lah. Okay. Jadi, angle dia adalah antara WX and S. Kita tak boleh pilih WY sebab dia 90 degree. Kita tak boleh pilih WY sebab dia 90 degree dengan S. So, 180 degree. Okay. So, if we calculate the work done by the gravitational force, kita resolve pula, kita pilih WX. So, it should be WX S cos angle dekat sini antara WX dan S, 180. Okay, so WX bukan W. So, WX adalah, okay, you kena resolve tadi kan? mg sin 25. mg sin 25. Tak muat ni, saya bawah sikit. mg sin 25 times S, 3.8 times negative 1. Okay? So, dapatlah jawapan dia. Negative 315. Sekejap ya. Okay, negative 315 joule. So, samalah jawapan dia akan sama. Boleh? Yang bawah ni saya tak kira lah. Yang bawah ni sama je macam tadi. The work done on the box by the reaction force, which is normal force, 0. Sini pun 0. The work done on the box by the frictional force, kita dah kira tadi. Sama sini. Sama. Negative 76 joule. Okay. And the total work done tak samalah. Okay. The total work done, kita kena tambahkan semua. Sebab kita dah kira asasing tadi. So, kita tambahkan semua. So, the total work done. Nak tulis W total pun boleh juga. Okay. Work done by the external force plus work done by the gravitational force. Normal kalau tak nak tambah pun tak apa sebab dia perpendicular to S. So, 0 degree. Sorry, 0 joule. Plus work done by the frictional force. Okay. So, kalau you perhatikan, the total work done, jawapan dia tidak sama. Kenapa? Sebab the external force tadi, arrow dia berbeza. Diagram yang keempat macam tu. Diagram yang ketiga macam tu. Diagram yang kedua macam tu. Tak sama kan? So, kita perhatikanlah. Okay. But surprisingly, for diagram 3 and 4, okay, you can see here, okay, the value. Okay, cuba you kira. Sekejap Yang ni betul ke saya kira ni? Sekejap F cos sekejap 250 times cos 60 times 3.8 475. Surprisingly, sini dia sama. Sorry, this one should be 475. Kenapa dia sama? Kenapa dia sama? Okay, sebab angle dia sama ni. 60 degree. The angle between F and S is 60 degree. Ya ke? Sama ke? Yang ni pun sama kan? Ni kita tersilap ni. Ini, sorry. This one adalah FX kan? FX ni betul lah. Okay, saya letakkan calculator. So, 475 degree. Same as to this one. Walaupun nampak arrow F dia macam berbeza. Ini tolak, ini tarik. Tolak, tarik kan? Okay. So, bila kita kira WF dia sama sebenarnya. Alright? That's mean when we calculate, the total work done should be 475 plus negative 315 plus 0 plus negative 76. Okay? So, you akan dapat kat sini 84 joule. Sama jugalah. Kat sini pun dia akan dapat sama sebab the work done by the external force WF ni, kita dah kira dah dekat sini tadi pun sama. Sebab angle dia sama kan. Cumanya yang ni arrow dia ke sini. 60 degree to the surface. And this is also 60 degree to the surface. Kan? 60 degree to the surface. this is also 60 degrees to the surface. So you can prove here that the work done by the external force for the fourth diagram here should be equal to the third diagram, 475 joule. Okay, so I think I will stop here, okay, for this video, how to calculate the work done, okay, for the example that involve inclined plane, and also for the work done by the force F that involve flat surface. Okay, so now I think we stop here, and then thank you for your support. So this week we just achieved 10k subscribers. Alright, so I wish you all the best. So make sure you focus on your journey, don't give up, just consistent, okay, in anything that you do. Alright, so see you in the next video. Assalamualaikum dan selamat sejahtera. Bye bye.